I'm Dr. Lennon, and I will just give you a little primer on the how of doing your fermentation lab this week. You get to decide to some degree what you're testing. You might be testing things like temperature, you might be testing things like pH, you might be testing different sugars or solids, you might be testing different juices. There's all sorts of things you could test, but in the end, there's only one way that you're going to actually measure the effect of what you did on fermentation, and you're going to use these fermentation tubes. So I'm going to give you the two different possibilities of ways that you might do this. If you are testing the effects of different solids, maybe different sugars, or you're testing the effects of temperature or pH, you're probably going to want to mix up your yeast as described in your packet, where you put your 10 grams of yeast in 200 grams of water. 200 milliliters of water. So I have that here. I'm going to take my yeast, dump it in, and then I'm going to just stir. I'm going to continue stirring until it goes fully into solution. You want to stir that. You want the yeast to become active. Right now, they're in a dried up form. They're little pellets of like thousands, at least, possibly millions of different little yeasties in each grain of yeast. And we want to activate them. So we're hydrating them. Now, we haven't given them anything to eat, but just like most organisms, before they went dormant, they stored a little bit of food so that when they wake up, when we hydrate them, they'll have a little bit of food to do cellular respiration or fermentation, depending on the availability of oxygen. I'm going to let that mix up. And this may take a few minutes. So if you've ever baked with yeast, you know sometimes it takes a few minutes to wake up from dormancy. You may want to stir this and set it aside. Do your other preparations while you do that. So you are probably going to want to use labeling tape today to label your tubes. A really good idea is to just label them right here, put a little piece of tape with the information on it. You'll also have little rubber mats on your table because these things are very fragile. So just be aware of that. They are very fragile. You want to make sure you put them on the yoga mat so they stay safe. And just be aware of them, because if you're moving your arms around over the top of them, you're very likely to tip them over and kind of ruin your experiment. So here's your fermentation tube. Here are our little yeasties. Now let's say that we've decided we are going to test sugars. So I'm just going to give you a little demo. You will have test tubes. You probably won't have these tubes, but these are really easy for me to grab to do this demo. You'll weigh out your solids, whatever your solids are, and you'll put them in the test tubes that we provided. I'd label those test tubes too. So there's your sugar or solid, whatever your solid is. Then you're going to take your yeast and you're going to fill this to 15 milliliters, because we want about 15 milliliters, 15 per sample. That's what fits best in these fermentation tubes. Okay, so there is our test tube filled to 15 milliliters. I like these test tubes, so I can kind of hope we get those put out. We're just going to shake it. Shake it like maracas. You're going to shake it until all of the sugar dissolves. So you can start shaking it, hand it to your teammate. They can continue shaking it. You are going to want to get this as soon as it dissolves into your fermentation tube. So we're going to get it to dissolve. And then once it's dissolved, you pour it into your fermentation tube. I'm going to come a little closer for this, and I can see the video on the projector, which is why you see me looking away every once in a while. So I'm watching to see what you can and cannot see. You take your fermentation tube and your test tube, and you just pour the test tube into the fermentation tube. Once the sugars have all dissolved, doing this a little probably ahead of schedule here. Now this doesn't work as is. So what we do is we tip it and tap it, tip and tap, tip and tap, tip, tap. And you can see it went all the way to the top of the fermentation tube. Now you can just set it down and you have started. So this is time 0. This is where you have started your experiment. You'll see along the sides of the tube, and if you aren't over 40, that there are graduations. So what will happen is as these yeast do fermentation, they're going to produce gas. The gas bubbles are going to escape up here into the tube, and they're going to push the yeast out of the tube. So you'll see it's graduated from 0 to 5, actually on this side. So you can count how many milliliters of CO2 the yeast have produced. So this is where you have to watch these. The maximum amount of time you want to go for this experiment is 45 minutes, or until we get to the 5 milliliter mark. Because if you go past 5 milliliters, you cannot measure how much gas there is. So watch these. If it gets to the 5 milliliter mark at 23 minutes, stop that experiment in that tube, write it down, and say you have produced 5 milliliters in 23 minutes. Now, if it doesn't do that, go the full 45 minutes and say maybe at 45 minutes, it's produced 2.3 milliliters of gas. You've done 2.3 milliliters in 45 minutes. And you're going to be calculating the rate of fermentation as a function of CO2 produced per minute. So make sure you look at that in your handout. So this is one version of what you can do if you decide to test solids, or if maybe you're going to do this and test pH or temperature. This is kind of your standard. I'm going to dump this out and show you the other option. Okay, so maybe you've decided you want to test different liquids. I have here cherry juice. And what I want to do, because if I mix this with this, it's going to dilute the concentration of the yeast too much. So you won't have enough yeast in there to see a good effect on fermentation. So you cannot have liquid with liquid. What you need to do is calculate exactly how many grams of yeast you need per milliliter. So we said it's 10 grams in 200 milliliters. Figure out how many grams that means there are in 1 milliliter. And then you want to calculate that for 15 milliliters. So if you need help with math, talk to your lab instructor or your lecture instructor. But you just need to calculate how many grams of yeast you need per milliliter so that you know how many you need per 15 milliliters. Okay, so in this case, you've got your tube. You've calculated how much yeast you need per tube. And you're going to put that in the tube first. Then you're going to put in your juice, up to 15 milliliters. Okay, and just like before, we're going to cap it and shake it until the yeast dissolve. And again, this is something you would do with any liquid. If you've decided you're going to be testing liquids, you're going to have to figure out how many grams of yeast you need for 15 mils of fluids, and then put that in each tube. And you can ask for help from your lab instructor if you need it. I'm going to tap this a little bit more. You want it all to go into solution. So I'm going to cover up the fact that I didn't do that because I don't want to make you wait while this goes into solution. We still need to put this in a fermentation tube. So make sure your fermentation tube is clean. You may need to rinse it out from the previous students. Uncap your tube. Pour your juice and yeast solution into the fermentation tube. And then, of course, we want to tip it again. So tip and tap, tip, tap, tip, tap, tip, tap. Get all the air bubbles out. And then there is your fermentation tube where you're testing your yeast against a liquid. Again, you'll leave that, see what happens to the amount of gas produced, and compare the rate of the gas produced, which is telling you the rate of fermentation, as a function of whatever it was you changed. When you're done, you want to make sure you dump this out. You want to make sure everything is clean and rinsed out as well as possible. So if you cannot get it clean, talk to your lab instructor, because we need to make sure that the next lab has the materials to keep it clean. Again, be super careful of these fermentation tubes. They are very fragile. All right, Dr. Lennon out. Let me know if you have questions.